Okay, so this next problem, I like these types of problems because it's an arc length problem. That's with a vector. So if you want to find the distance traveled, we'll call it S. Because most textbooks do that. And we know it goes from B to A for R prime of t's norm dt. And B and A are both time variables in this case. So what we want to do is we want to find, well, we know what B and A already is, so we can replace B and A with 1 and 0. But then R prime of t, we have to actually take this derivative real quick and then take its norm and put it over here. So let's do that in a different color. Let's do that in black. So R prime of t, it's just the time derivative of this. So let's make sure we take it properly or else everything will mess up. So again, derivative of polynomial, then comes down, subtract from the top, right? So it's going to become t, and then 5 over 2 minus 2 over 2 is 3 over 2. Minus, and then we got 2 times 3 over 2 then, right? I'm just talking in terms of taking this derivative. That's going to be negative 3t, and then 3/2 minus 2 over 2 is 1/2. Okay? And then we'll get negative 4t for this interval. Not for this interval, I mean for this section of the vector. And then for this section of the vector, what do we get? The 3/2 comes over, then the 3's go away, 8 over 2, it's 4. Then 3/2 minus 2 over 2, it's 1/2. So this is our vector. Okay, now let's take the norm of it. So when we take the norm of that, means we're going to square everything in here and then add it. And then take that square root. So t 3/2 minus 3, t 1/2 squared plus negative 4t squared plus 4t 1/2 squared. Okay, so what does that become? Okay, so the t, real quick, we'll go in green and do it over here for the just this part because I don't want to actually write that out. Okay, over here. So t to 3/2 minus 3, it's the t 1/2 times t to the 3/2 minus 3 1/2. What do we get? So it's going to be t to the 3/2 plus 3/2. That's 6 over 2, so that's 3. Then 3 times that, that's going to turn into positive. My bad, that's not positive. Negative 6t, and then 1/2 times 3/2 exponentially, right? Sorry, my bad. What I'm doing is this right here, and then times it by 2, that's why there's a 6 here. So 1/2, 1 plus that, right? That's 2 over 2. 4 over 2, which is 2. And lastly, we get plus 9t. Okay. So that's all I did. Okay. The reason why I had to do that over here on green is because this is, I don't want it to expand too big when I'm doing it inside the square root. Okay. So here we go. And I'm going to add that to these guys. So I get t cubed minus 6t squared plus 9t, and then plus 16t squared, right? And then plus 16t. Okay, so as we can see, what happens here, so we have a 9t and a 16t, that's going to be 25t, and then we have a 16t squared here, minus this guy, which is going to turn into a positive 10t squared. T cubed stays by itself. T cubed plus 10t squared and plus 25t. And as you guys can guess, we can factor out a t.
She can't call very often. They only have certain times.
And then 10t, so then this turns into quadratic. Imagine it's a quadratic here. Then we want to factor it, and presumably it's t plus 5 squared. So let's just check real quick, and I'll erase it. T plus 5 t plus 5 multiplied by each other, we get t squared plus 10t plus 25. Yes, that is correct. Good job. Good job, me. Okay, so this is our thing here. And then as you can see, this, what does this reduce down to? This reduces down to t plus 5 square root t. That's what it reduces down to. Okay. So now we can put this guy back up here. Although I'm just going to write it down here. So we get 1 to 0, square root t plus 5 dt. This is the same thing as the integral from 1 to 0. Square root t times t is t to the 3/2 plus 5 t to the 1/2 dt. Now if we take this, what do we get? We get t to the 3/2. Then you add the 1 up top, so it's going to be 5 over 2. Divided by 5 over 2. Plus 5 t to the 3/2. Divided by 3/2. Evaluated from 1 to 0. So if you put 1 into here, just 1. You put 0 into here, everything goes away. So let's just put 1 into it. So we get 1 over 5 over 2 plus 5 3 over 2. And yes, we'll write this properly. 2 over 5 plus 10 over 3. And we know that this would come out to what? So let's find a common fraction here. It should be 15. So times that by 3, we get 6. Times the other side by... Hold up. Yeah, times that by 3. Times that guy by 5. 56 over 15. Yeah, I'll write it over here. 56 over 15, and that is the distance traveled for this vector from that time.